Doctori, tutto a posto? Welcome back to a new video of Sane C Libraries. So, Sane C Libraries is a set of platform abstraction libraries for macOS, Windows, and Linux. These are the principles, so it's like fast, super fast to compile, it's bloat-free, it's very simple and readable code, and it's easy to integrate. It doesn't use any part of the standard C++ library, and it has no third-party dependencies. So you can check it out on GitHub at this URL that you can find, of course, into the video description. If you want to get in touch, you can join the Discord, or you can contact me personally on Twitter, Mastodon, or even here on GitHub discussion. One more note for this month, I've started creating releases, and I guess I will try to create a release every month. I'm not using like semantic versioning for the project, at least for now. So all the versions are just the month name here and month name. So I guess that's good. So let's get it started. So what are we going to do today? Today I would like to do something really cool, which is creating. How can I create a terminal here? Here, okay. Creating, basically implementing the ThreadPool into the asynchronous IO library. So let me explain what's the problem. Currently, in the async library, we have a bunch of operations like the file read operation. Let me find it. File read, async file read. So this is like a asynchronous operation that you can have to read some bytes from a buffer and from a file descriptor into a buffer, and the operation will be done. Eventually you can even consider using an offset, and the callback will be called. The problem is that on some platforms, actually on all platforms with the exception of IOU ring, I think, the these operations on this operation on regular files that are not open for direct IO are actually synchronous operations, and this is you can look up the documentation if you want. I can provide the links in maybe in some comment. Please let me know. But it's basically stated that you should really run that call into some sort of thread if you don't want to be blocking. So this is a little bit sad, because all of our fancy infrastructure that we have been putting in place, for example, in the async POSIX, like for I don't know, write, will not be doing an actual asynchronous write. So how can we solve this? So what I have done in the previous video, and then have been also tweaking it over the time, because I think in the video there was even some bug, is creating this ThreadPool class. So this ThreadPool class allows us to create tasks and schedule them on a thread pool, and there will be a number of threads that will be executing those tasks, and so on. So I would like to use the thread pool to run the asynchronous file read and write operation on a per operation basis. So it will be the caller, the user, that will decide if the operation needs to be run into a thread pool. So where do we start? I would start by including the thread pool. Actually, no, we can forward declare it, because this is the public header. I'm always trying to keep the public headers free of unnecessary includes. So let's say struct thread pool, struct thread pool task. All right, then I would like to create a couple of structs to hold the actually let's start with one to hold the asynchronous tasks, the thread pool task. So let's call it async task. So what will this async task do? Let's see. Async task, what do we need? I think we need the thread pool. We need the thread pool task. Let's say just task. What else do we need? I think it's fine for now. I think we may need to add the result. Yeah, we definitely need the result because, yes, so we need a pointer to a result or a reference to a result, because if we need to complete this task into some sort of background thread, the background thread we will need to store the results of the execution. So let's say async result, I don't know, result. All right, the problem is that the async result is an object that has a different type for each completion. So how do we even store this? So we cannot ask the caller to use an async task. We should probably create some sort of how do we call it? Let's say struct async task of, I don't know. These are terrible names. Yeah, well, I guess this will work for now. So let's say we create an async task of t, and what do we put inside of this one? Type name t. I would like to put so this will be my actual result. So every async operation has a result nested class, which I can call, just result. So you can check, every async operation has a result object, which is either just, using declaration if it doesn't have any custom methods, or, there is a literal object called result. So we say result, I don't know, async result. Yeah, or maybe should I call this async result? That's all right. So when building it, someone will pass yes, a ThreadPool and so ThreadPool and a ThreadPool task, and so we can derive this from async task publicly, and call the async task constructor with the ThreadPool and the task and the result. What do you think about this? Is it fine? Does it even compile? I mean, I would like to go in the Xcode. Yeah, let's say in the Xcode. Let's continue. We started in VS Code and we continue in Xcode. Do you mean ThreadPool task? Of course, yes. And we don't want to update to the recommended settings. I should fix this one. All right. Now, where do I put the async task? I think we need to store the async task in the async request. Yeah. Which is totally optional, so we save it as a pointer. So pointers in Sane C libraries always mean optional. I guess we could even, we could be saving some bytes here by saving the, by doing the, let's say the union with the event loop, because you can take the event loop from the async task, but maybe we could use some sort of flag, but I don't know. This is just to save a single pointer. We probably don't care for now, at least. Maybe future optimization. Now we have, I think the data structures are really what they should be. Let me try to, let's see, the test, async test. So how do we want this to be used? So I will maybe add like a bool, so no, not to this one, sorry. let's take the file read and write. Let's add a parameter to say use ThreadPool, so we can rerun the read write with or without the ThreadPool. So let's say no ThreadPool. Yeah, use, do not use. Now, what should I do with the use ThreadPool? I think I will create an event, ThreadPool. And if use ThreadPool is true, I will create the ThreadPool, I don't know, with 4 threads. Expect, all right. Yeah. And I want to create a ThreadPool task. I don't know, async write task, async read task. So the idea is that I can create should be adding here the using task is async task of async file write, and the same for the file read. Async file read. So this is basically telling us how to build this object that has a result and pointers to the ThreadPool task and to the result itself in a way that we can type erase it. So async file write task will be async write tasks. So this clashes with this one. So let's say write task and read task. Yeah. So I need to pass the ThreadPool and the write task, right? And the same for the file read. So this is how you will be doing let's say ThreadPool write operation. Oh, why is it implicitly deleted? What are we not doing? Oh, because result needs, yeah. I think building a result requires an async object. So we need a T, async, and a result. But now, of course, we need to say to add the async file right here and the async read file here. No matching constructor. Can we do this here? Okay. ThreadPool. All right. So the idea is that now we can pass the async file read task to the start. So when starting, we should be adding like optional parameter. Let's say async. Actually, just task. Yeah. I mean, we will type erase it anyway, but let's say this is let's call it task so it doesn't clash with the async task. So I'll do this for the read and for the write. Now this is complaining about, of course, us needing to update the corresponding methods. Unused parameter task. So I would like to add the query submission, async task, task. No, this should be optional. And so this is a task, and we want to be passing it here. Async task queue submission. We had basically we have been adding this async task parameter everywhere, so it's routed. Of course. So task here, task here, and all of these queue submission, we can just make them no PTR. Now we have in the queue submission we have the task. So async dot task equals task. Now I would like to add a to do here. Let's say figure out a way to disable the async task where it doesn't make sense, like IO ring. So if the user is passing an async task on an IOU ring backend, it should not be using it because it makes no sense. It just will not be adding any value. Because in IOU ring, the operations are already asynchronous. Also, there's all of these file operations. All right, so I have been preparing a little bit for what I'm doing today. So if you see the commit before the one that I will be pushing here, hopefully when I will complete this ThreadPool implementation, has all of these new async phase objects, which are kind of a way to do a bunch of generic operations on each phase. You know, we have the phases. If you see some previous video, we have the setup, the activate, the tear down, and the cancel phases, and the complete, of course. Because it allows us to write generic code that is parameterized on the specific async request type. So I can hook up here and say the setup is the first phase that it's being called. It's the one that typically sets up the, for example, the listeners for files into the kernel queue. So if we have been asked to do an async task, I think we should just return a result true, because we don't want to call the OS facility to do the setup. Let's see, for example, what's being done in the POSIX backend. In the POSIX backend, we are setting like the event watcher, which is calling this evset on macOS, and on ep.14 it's calling something else, which it's the ep.14 ctl add, I think. Yeah, this one. So we want to avoid all of these. And so when we have an async task, we will be skipping the setup phase. Now in the activate, if we have an async task, what should we be doing? If we have an async task, what should we be doing? I think, yeah, this is where we really need to do the bulk of the work, because we need to do the execution of the start the execution of the operation. So let's say async task async task equals this one. I'm doing it so that I have a little bit of code completion. So I have my ThreadPool. I can queue a task, and I will queue my async task dot task. I should probably try it. This is cool. What do I need to how do I set up my task? So my task needs to have a function. This function, what should this function do? I think we have to call the execute. How did I call them? I don't even remember. I have already been splitting execute operation. So this is what was typically done in the completion or in the activate on some other operation, which is the actual operation that we want to make async. Because by splitting it into a dedicated file which just has the input, the async operation, and the output, this completion data, I can call it both asynchronously, which for readiness-based systems like ep.14 and KQ, it means I can call it, let's say, when I know that they are ready, so I know they will not be blocking. And for Windows, where this is handled with another mechanism, I can, well, which I should probably be modifying, I guess. For example, write file. Yeah, I can just add like a synchronous parameter here and call it, with the regular code path, say, hey, I want to do this asynchronously. And when I'm using the ThreadPool path, where this one will be called on another thread and will need to be run synchronously, I can know it with a parameter. Yeah, let's add it. Bool. Well, let's add it later if we ever get to fix the Windows version. I don't know, because I will cut the video when it becomes too long. So this will need to be execute kernel q execute operation, right? Yes, but it depends on the operation type. So let's say execute operation with the result dot result. Yeah. Yeah, I guess this is okay. Let's do static. I don't like doing too much code in the lambdas. This is a lambda. It doesn't even look like a lambda because it does not have the parentheses, but it's a lambda. Trust me. Execute operation. So this is executed on the thread. This runs on a random background thread because we are queuing the task. Let's say we have an async result of some kind. So switch result dot async dot type, and I want to have async request type file read and file write. Of course, we want the case. Yeah, let's default all of the others. Actually, I guess we can assert here because we shouldn't really be arriving here. C assert release, I don't know, unsupported operation for ThreadPool. Yeah. Ooh, we have a static assert failure. Oh, the lambda. What am I doing wrong in the lambda? I should be grabbing this by pointer. All right, yes, because our function does not allow heap allocation. So by doing this, I know I can only store a single function pointer, which is cool. So result.async.asyncTask result. Well, I guess we have too many results. Let's say async result. No, what should I do here? Here I should be So what is this result? This is the result of the async. All right. I need to call the kernel queue execute operation with an async file read. So I need to static cast my async file read. So let's create this async request async, and I need to static cast is async file read completion data. Oh, that's long, completion data. I should probably rename it. No, maybe not. Result, just result. So this result is of type file read, for example, and I should be running this result.com. No, I should be. So this is an async file read result, and I should be taking the completion data, ignoring return value. So we are invoking the synchronous operation, you know, and writing the results. So for example, how many bytes have been read from this read operation. Now I need to store the result. So this is result return code. Yes, it's a result object. Excellent. Let's do copy and paste here. Oh, async file read, async file write. All right. Let me format the code. That sounds reasonable. So we are scheduling in the activation, we are scheduling a function to be run on a background thread, and we are just executing the operation, saving the results and the return code. Now, I think we need here to, interesting, because now I think we need to be adding this to some sort of a linked list. The problem is that we need to be signaling from the linked list when the operation is finished. So like here, to do, let's say, insert a result into linked list. Not the result, actually, the async task. And then we need to wake up the thread, the event loop. So async dot event loop wake up from external thread. So let's create this, how do we call it? ThreadSafeLinkedList. Because we don't have a ThreadSafeLinkedList. I guess I should have been doing this earlier, but this is going to be not super easy. Let's say yeah, this will be a detour on writing a ThreadSafeLinkedList. Next. I don't know, prev next include threading. This is getting so hot here. All right. Shaky camera movement. Is the camera still centered? Yes. Mutex. So we just need a push and pop. Maybe let me take it back here. So let's take the mutex lock, mutex unlock. So prev, not prev and next, sorry, what am I doing? I need to do head and tail. So if head, let's set them to null PTR. So if we have a head, actually if we have a tail, we can say tail dot next is object, tail becomes our object. So we make the last item in the tail to point at the current object, and then the current object becomes the last item of the tail. And otherwise, we make the head and tail to be our object, because it means we have an empty queue, right? Void pop. And we want to have a T. We do a mutex lock and unlock. And so if tail, if head T current equals head equals head next. Actually, we can do this anyway. Return current. Instead, if we don't have a head, it means should we make the tail null PTR? Here, if, yeah, we can do it outside. So if not head, tail is null PTR. Actually, let's make it explicit. If head is null PTR, tail is null PTR. And we return the current. Okay, we have probably buggy, but we can try it. ThreadSafeLinkedList. Yeah. Let's do it. Let's add it here. ThreadSafeLinkedList. I should include it. Include ThreadSafeLinkedList. I'm keeping it here in the internal because this is not really, meant to be general purpose. So, I mean, maybe we could evolve it, but for now, For now, it will be just an internal implementation detail. ThreadPool manual ThreadPool completions. So does the async task have a next? No, async task next. Otherwise, this will not be working. Does it compile? I should also regenerate the project, probably, yes. So I can get my ThreadSafeLinkedList here, ignoring return value. But I guess we can only assert here. Cool, this even compiles. So async dot event loop dot private self manual thread pool completion push. We need the async task, so I should probably push the async task here. Task async result result equals async task dot result. Async task. So we are pushing this async task into this completion. All right. Where is the completion? Completion is here, where we call the complete. So here, where is this return code coming from? Oh, from the previous phases. Okay. So if we have an async task, what should we be doing differently? Let me type it here so I can have the completion, the code completion, because I don't remember names of the fields. The async task. So this is now completed, because if we are called here, actually no, this will not even work, because still need to be marshalling the this guy here. So I need to take all of the completion that we are pushing here and do just another step. Run step execute manual thread pool completions. Yeah. So I can have my manual thread pool completion. Should probably uniform the name of these items. Async task. And then we just take the async task dot result get dot async. Of course, this method does not exist. Let's add it. And use it variable async task. So now that we know that we are marshalling the basically this is parallel to the manual completions. So manual completion get executed. They are just like completions. So like end of an asynchronous life cycle, like the operation is is finished and you want to call the callbacks. We have this concept of the manual completions for objects that are not being triggered by kernel OS API. And now we have this manual thread pool completions. So now that we have this thread pool completions, I should be able to be called here. Well, we will debug and see. It should arrive in the complete phase. So let's say result async request What should I be doing? So in the execute, we are writing the return code and we are filling the completion data. Correct. So now I should copy this completion data somehow. So I have, this is, so this async, oh, I already have the async. The async is already of the correct type, so I can say, and even the result type is already correct, so I can copy return code for sure. Result return code. And the completion data. So every result has a completion data. I cannot do this, right? Yeah, because this is the generic, this result is the async result. So I need to cast this to the specific type. Okay, all right, let's say switch. No, I just need to cast it. I already know the type. So static cast async result type. So this is the result type, and we should be able to get the corresponding. Siri just agrees with me. Completion data. Object of type cannot be assigned because the copy assignment operation is deleted. Oh, we need to move it, and then very cool. One thing that I think we should be making is waiting for the task, because even if the task is finished, we need to wait for it, because otherwise it will not be flagged as reusable. And so we wait for the task, and I think this should be good. So let's say, let's hard code just to run the async test. And in the async task, let's hard code it to just run this fancy. Well, first of all, let's see if we have not been breaking anything. So I'll disable this test and run all of the suite. All right. Now I'll do the reverse. I think I should still be adding the, yeah, use ThreadPool parameters. So use ThreadPool, we should be passing the task, otherwise no PTR, and the same for the read. Where is it? Here. Sorry. We use ThreadPool async read task, or no PTR. Address off. Cool. I don't know what will happen, but I guess we can start running this. Run. No, wait a minute. We are executing way too many stuff. What's going on? File read write. Why are we? Oh, don't tell me that this went through. Oh, that's I don't believe this. I mean, I've been planning more or less all of these operations. As you may have seen, I had already very clear idea what to do, and I know this code very well because I have been refactoring it heavily. But I do not expect this to work. So how is this even possible? Let's see that we are actually running this on a thread pool. The easiest way would be to go into the execute operation and raise a breakpoint, and we should not be on the main thread, on both here and this other one. We are on thread 1. Okay. Okay, so this was working, of course, because I'm not running the thing. Yes, because I'm running the do not use ThreadPool test. That would have been way too easy. Oh, actually, also this one is working. Cool. Yes, we are on thread number 2. And as you can see, our main loop is just waiting on the key event or whatever is the asynchronous async IO event loop IO call. And this will get unblocked when we return from one of these calls, like this one. And we call the wake up from external thread, which, you know, it's something we did in the past that is really, really useful. So this works. Well, I'm pretty sure there are probably a billion edge cases that I'm not handling, and this is really, really great. How much time do we have? 47 minutes. Yeah, this video is long. So I guess I can cut the video here. We can stop it. Let's enumerate the things that I will need to be doing before committing this. So one thing that I will do to make this run on Windows is definitely add a parameter here like bool, I don't know, synchronous, and so in the regular activation where this is called, I will need to say false, and will run basically the same as right now. But when the synchronous is true, I will need to do the get overlapped result such that I can wait for the write file or the read file to be actually finished. I'm not 100% sure because I will need to do this if the file is opened and already associated with an overlapped IO object. I'm not 100% sure if I have a file open for regular synchronous IO, if this will work. I will probably get the right file to just succeed at that point, yes. So I will investigate this later. You will see this in the commit. Yeah. And if you see anything strange, let me know, you know, in the comments or on GitHub or on Discord, but I think this should be relatively easy. And on Linux, on the IO ring, I think we should just need to make sure we are not using the thread pool at all. So maybe some filter method that will be conditionally defined on all platforms will tell the system what to do. So I hope you enjoyed the video and that this was kind of useful to you. I know if this is, I mean, this is information specific to Sane C libraries, but I think you may have found useful understanding in looking at how the library is being developed. And again, if you want, please remember to get in touch on the Discord or on Twitter or Mastodon, and have fun, download, clone Sane C library, and see you at the next video. Bye.